Hey guys, welcome back to the channel. This is going to be a short video testing MEFi for William Fowler. He is in Middleborough, MA. He's saying this is 2005 four wings 210 Horizon. It's a Volvo Penta 5.7 GIE. Again, this is William's computer. This is for him to so he can see the numbers, so he can see that that's indeed his computer. I'm going to turn this back on because it's running for a little while, but everything is fine. So we got the 5-volt reference. That's the IAC valve, and that is the whole ignition system with a substituted value for the coil, so I don't have to have a sparking coil in here. Um, the boat has been running for, what is the minutes in here? I just saw it before. Hours. Right here, 7.67, and the counts are in order correctly. I did have all for injector 1 and 2 open in history, and I had that saved for you. Let me open the folder, which I thought I have ready, but I didn't, so give me just 1 second. FE4. Oof, I hate that pinning on my ear. 5.7 GIE. Right here. So yeah, as you can see, let me just zoom in here so we can see this more. William Fowler, this is just now. Today's the 8th of October. Um, Again, checking your computers. I usually do it with no ignition. I mean, just ignition on, no RPM. You can see the side idle speed. But if I go over to the actual engine running time 0, and let me see what the RPMs are right here. No, log RPMs. Come on, right here. Engine speed 0 RPM. So right here, 0 RPM. So this is just me connecting it to the computer, to the scanner, and these are the faults that were down uh, in history. Injector A low or open, injector B low or open, and you shut down telltale set. Um, Nothing to go by. The fault is not happening in here. As you can see, you got, let me see if I have the fault codes. Let me see, start without faults, I think. Yeah, start with all malfunctions, 1. So let me just put this on the zoom. Not that one. Well, actually, I need the throttle position, so no problem. So start with all malfunctions, 1, throttle position. Um, we can get the engine RPM, which is 623 as I am running now. Let me see if I have injector. Yeah, injector bank 1 and injector bank 2. So we can see that those are indeed working properly. And if I compare to that, there's always a little difference in between what the computer wants and what is given, but I have checked with my oscilloscope, and that is actually right in only three milliseconds. Yeah, so I'm going to raise the RPM, so you can see now that I'm going around 2000. I'm going to go over to like around 4000 RPMs. Right there, let me raise the throttle position so we got some more accordingly to that. But now we can see a very nice and bright coil. So because why is happening many more times. Obviously, the injector millisecond now raised also as well to 3.6, 3.8, and that's going to change if I give more map mass sensors value, because right now, let me see map, looking for manifold air pressure, and right here. Did I click the, well, I clicked the voltage, so I might as well just leave it, and we're gonna get the pressure as well too, so we can have those two pits. Again, guys, for those that are technicians and the ones are not technicians, each of those lines we see here are called pits. And it's just, sensor data specific for each, sensor, injector, computer values. But yeah, so if I bring down now the RPM, I'm just going to focus on that light. I'm going to get a little closer, so I'm going down. I hope that you can see now the getting dim. I'm going to go down to idle again, around 600. 650, let's say. Let me change the throttle position to around or less than 10%, right? But yeah, now we can see that light less brightening. All right, so everything is showing good. Things I was going to show, if I change the map value, I can change the injector millisecond. You see, when it went to 4%, the same thing is the result in the computer. So I'm going to change the map manifold air pressure. That's going to change how much the injection is going to be. I usually use 12.5 for my testing here. That's kind of like across the board, so I get a good idea what the computers are is reading and if it's anything abnormal or not. Again, the IX is working good. Your computer is working perfectly. I'm going to turn this off. All right, so I'm going to turn the ignition off, and we're going to lose communication. Just in a second, you're going to see, okay, you see that? Now I'm going to establish the power on again. That's going to synchronize again. Now we are back in business. 5 references there. I'm going to do that again so you can see the fuel pump coming on as a prime, which is the normal way. Again, ignition on, fuel pump comes on, and then goes off. Perfect. I'm going to show you that the 5 reference is indeed coming from the computer. So turn them up in computer off, computer back on, and we got the 5 reference in there. So all is normal. And then just run the computer. Come on. Don't let me down. Too many power off. All right, so we got a no start now. It's definitely not showing RPM. And this was after I did a couple of starts. I'm just, touching the crankshaft and camshaft sensor signals in here to make sure that that is not the one preventing the vehicle from a start, or both from a start. Computer didn't lose communication. I'm synchronizing again, so yeah, that's what I'm doing in here, trying to get the computer to react. So let's read codes. No trouble codes found. Let me turn everything off because I can see a signal, but I don't see any RPM. And this is pretty much what he says. He's lost because reading his information, it says ECU crank no start, no spark, no signal from ECN to ignition module from J2 connector pin 31, no gauges working, battery or everything. Oil pressure and RPM gauge. No gauges work. Battery voltage, fuel level, oil pressure, and RPM gauge. Thanks for taking the time to diagnose my ECM. I got this boat now running and I was told it run but needed a starter. After replacing the starter, I found that I had a crank no start issue that after further diagnostics tests, it came to the conclusion of a faulty ECM. After following the ignition system diagnosis test in the MEFi diagnostic manual, prior to the diagnosis test, I found that the crank sensor looked to have been replaced along with the connector plug. Same goes for the ignition coil and connector plug and ignition control module and the connector plug. After pinning out the following wire diagrams, I confirmed that they are all wired correctly and have continuity between them. Let me just cover his information. Continuity between them all and the ECM main J connectors. I also found, I'm at the bottom of the line, like 4 lines up. I also found burnt melted wires on the back of the radio between 12 power wire and a ground wire where the fuses never blew on the power wire. Hope this helps, and for any further questions, feel free to call me at any time, 7 a.m., 10 p.m. any day. Thanks. All right, so no fault, but no start. Right now, the computer is not reading as I start. So let me just do one thing. I'm going to re-inject my signal. So the computer is off. As you can see, I lost communication. I'm going to reselect my signal from my simulator to make sure that's not has lost a sync for any reason. because I was, on and off and on and off trying to show that. But let's do this again. I'm going to write that signal into my simulator. All right, so those are signals I created it. Okay, we lost communication, that's fine, but I can see that the fuel pump is responding accordingly. So we do have fuel pump signal. The ignition switch is on. Um, I don't need to really establish communication, but yeah, there is no. I'm changing the voltages on the cam and crank sensor signals. Um, Changing the speed in here. Nothing has changed, and not is no response. So this is definitely a problem inside the computer. All right, guys. So this is great because I was like you saw before, able to connect to the computer. This is going to be no problem. I connected to mode 0, and then this is how you read faults. It says so far I got 0 faults and one start without malfunction because. So I was saying that for the computer, the engine is not running. It has not seen the crank sensor signal coming in. So, yep, at least lucky for me, he opened this computer before sending it to me. As you see, we have tape holding the cover. So I'm going to open this to see what I see. He couldn't find anything wrong, at least obviously by the naked eye. But we'll see. Because right now we are 100% reproducing his concerns. So, William, yep. So it looks like you were right in the money. The problem is here. And I was happy to see at least the computer running for a little bit. Hi guys, following up with William Fowler computer. As you can see, I got it open. I checked all the pins or jumpers in here because this is one of the ones that the fluid, the gel slide, like probably they didn't let us set up properly and attach it to the engine, and then in the position all the gel slides to the bottom, but all those jumpers are fine, so that's not the issue. So again, right now the computer, well, is connected and communicating, but I have the cam and crank sensor signals injected in, and it's not working. We can see I have one, now I move my leads, and I have now red channel, connected to the cam sensor and the simulator. And I'm using the other one just to poke around and see what I found. But I also, well, I see that the cam sensor signal, oh, sorry, the crank sensor signal is not going through the IC, which is supposed to go through, which is telling me computer is shorted. So I went ahead and did a thermal camera test, and this is what I found. All right, so this is again the folder for William. History with the computer running at first. This is just the computer connector before I open it up, so I have all the information in here. Let me put this on bigger screen. Let me go back to Alexa. Let me go forward. So I save a few pictures of the computer being tested. The nice thing about the FLIR camera, I got the FLIR 1 Pro. You can connect to the iPhone. This is a snap photo of the screen so we can see what I was doing in there. In this one, you can open the bottom and it has a like a tab that you can click in there, and it tells you to put, it lets you put, even manual, so you can change the scales because when you raise the temperature, it will eliminate to see all these yellow, and I'm going to put the cooler areas on purple and the hottest areas in yellow, so it's a lot easier to see on the naked eye, right? And then you can select to have this blue, which is the coldest on the screen. Again, on the thermal camera, we can see 74.5 degrees. Again, the computer is connected. That is okay. And then the hottest point, and then I put another one so where I can measure the hottest point on the board and then the one next to it. This in here at 117 degrees, and this one's 112 with the computer not running. So we have a problem. It's a short. The problem is what those components are. I have explained a few times in here that these, again, let me just show more pictures, closer pictures of that thermal location. I was just reading and trying. You see, this is with the scaling auto. you just see everything yellow, and you can see, higher temperature areas, but it's a lot harder to see that when you adjust the scale, and now everything else is in dark, and you just focus onto the hardest part. We do have some other areas that are warm, but again, not abnormal that a computer is connected and talking is going to warm up. But this has a very heavy heat dissipated dissipation sink area. All these things in here, and all this is there for that to dissipate temperature. And this is, I can feel warm under it without even running it on the boat. But yeah, so I want to show also a full picture of what the MEFi 4 board should look. I have one here with all my notes. All right, so yeah, this is the one area that I want to show. Let me see if I can flip this so we can see kind of like the same way the thermal camera is. Give me just 1 second to put everything so we have everything looking the same. All right, perfect. So, uh, this white yellowish is right here. We can see that, right? And then underneath of that, we have this crystal IC, and in these two crystals IC, that's the voltage regulating on this computer. And it's made out of crystal. It's not replaceable, and that is where the short lies. This is the 5-volt regulator. This is 12-volt regulator, all built in because this has some, as you can see, I have marked in there 3.35 volts, etc. around it. There is not just this part in here. There is some more areas on the board that are part of the 12-volt regulator, but this is the 12 volts entering onto the 5 volts. And that's where the short is. We can see right there. Yeah, there is no doubt about it, and I cannot repair this. This is where technology stopped me. This is a crystal ceramic board that has, again, a lot of components that I can repair and I can fix when problems are in internal pads. I am an expert on these computers. I know how much or where they go, and I can repair those, putting jumpers, or sometimes just fixing the pad, which is a chore. I got a lot of tools, a lot of um, specialty components that are meant to repair boards, but nothing for uh, like these crystal um, components are print, let's say, with the board. They're just put in there, solder, and it's a one-time use. You cannot repair. Let me see if I have pictures or more pictures of some of the components being removed from the board, which I know I do have for the MEFi 3. Let me just see. I'm just looking for those pictures without actually putting the camera right there so I don't have, or I don't share all that I have here, because not everything is to share, right? But I want to share some. Let me go over to the MEFi 3, which is MEFi 3 and MEFi 4. They're very, very close to each other on some areas. Let's say this is the IAC driver from a MEFi 3. That's the underside layer of that driver. This is where the IAC driver will go. As you can see, I have removed from, burn boards, ones that I use as um, guinea pigs, and then I start again knowing how every signal and everything works. So yes, this is hours and hours and hours of me learning how to repair these computers. This is not just, oh, where do you guys a lot I found sometimes funny, it's like, hey, Mike, where do you find all that information? I didn't find it. I made it. I took the time to uh, get a bad computer, a good computer, remove the components, follow the paths under the board, and understand how it works. Yes, hours, hours, and hours, and hours, and hours of finding this. And I mean, not find it, make my own information. And that's how I, at the end, I can tell the customer like this, yes, your module is not repairable. This is something that, yeah, you can send this to Volvo Penta and they will take this as a quarter lease and you can save some money, and they send you a new computer if they have it. But yeah, well, William, I'm sorry. This is again as much as I can do for you, a test, but at least you will have at least an answer, a correct answer that yes, the problem is here and not on the boat, and you can move on and to decide if you want to find another computer or not. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. I hope that you guys are liking the content. I'm trying to share as much as information as I always do. I have gathered hours and hours of information that I have put together in order for me to be able to test properly these components, these computers. I can share, if you need, ever need a wire diagram or locations of how the computers are connected. This is for the 5.0, 5.7, 6.0, and 8.1. There is a little difference on the 8.1, but yeah, these are the connections that I use on Diacom, and whomever has a Diacom. If you don't have the original connector, you don't need it. All you need is to provide on the Diacom cable. This is going towards my um, laptop or a PC, right? And I am providing power and ground to that from the let me see, from my simulator, because that is power and ground that will be provided for this to communicate, and then the serial and transmit are J210 and J12. If we go over to J210 is serial data, J12 diagnostic terminal. Yes, you don't need to have that connector. You can just use because the 94006 is not made for MEFis. But again, I don't really need to have the MEFi one. MEFi one, I think, and I have it. Let me just show you in a second how the MEFi one is. It looks. This is how the MEFi one, MEFi 3, and actually MEFi 1 and all those connectors look. That is part number 94005. And this all it does is just got those same pins. Again, it's a 4-pin connector, as you can see there, in different locations. Since I am doing my own wiring, I just use a power and ground steady in there, and I just connect the serial and diagnostics, and I can then use just that same wire for multiple computers. But yeah, so that's how I do, and yeah, I do my homework. I find online how a reluctor for the cam sensor should look and how many teeth has in the same thing, how a crankshaft reluctor wheel should look. And this is, like I said before, this is a very special uh, crank sensor signal because it's like a two wheels on one, and that's how the tooth on that signal should look on my simulator. So this is again cam on the top and then crank on the bottom. So yeah, that's the sync, a perfect sync, and that's how I do it. All right, guys. So again, sharing some information for the ones that like to know. And yes, this is how I work. I hope that you like the content. Don't forget to subscribe. See you next time. Bye bye.